mutual inductance of two long solenoids. Here there are two solenoids, S1 and S2. Their specifications are: common length is small l, radius of inner coil. Here this loop, this one, has a radius small r. Radius of outer coil, these loops which are bigger, is capital R. Area of each circular loop of inner coil, the smaller one, is pi r square. Area of outer circular loop is not to be considered. Now, number of turns in first coil is N1 and number of turns in second coil is N2. Number of turns per unit length can be found like N1 equal to capital N1 divided by L and N2 equal to capital N2 divided by L. Now, suppose current is passed through secondary coil, then it gives rise to magnetic field. And we know that magnetic field due to a solenoid is given by B equal to mu naught Ni. So here we can write B2 equal to mu naught N2 I2, where N2 equal to capital N2 divided by L. Now, total magnetic flux linked with inner solenoid S1. So flux linked with inner solenoid S1 is suppose phi1. So phi1 equal to magnetic field due to secondary B2 times common area or area of smaller coil times number of turns in inner coil. So now we can put the value of B2 as mu naught N2 I2 times A times N1. Now, mutual inductance of coil 1 with respect to coil 2 is written as M12, which is equal to phi upon I2. This is from the fact phi equal to Mi. So M12 equal to phi upon I2. So here this is phi. So phi1 divided by I2. When it is divided by I2, we will be left with mu naught N2 A times N1. But N2 can be replaced by N2 upon L. So mu naught capital N2 times capital N1 times A upon L. So this is M12. Now we reverse the process. That is, current is sent through primary and then it will give rise to magnetic field. So magnetic field when current flows through primary will be B1 equal to mu naught N1 I1, where N1 equal to N capital N1 divided by L. Now total flux linked with outer solenoid. So that is, this time we find phi2 equal to magnetic field due to inner solenoid times area of inner solenoid times number of turns in outer solenoid. So that will be magnetic field will be mu naught N1I, mu naught N1 I1 times capital A times N2, which is equal to N1 can be written as small n1 can be written as capital N1 divided by L. So we will get mu naught capital N1 capital N2 A times I1 divided by L. Now we can find mutual inductance of coil 2 with respect to coil 1. So we write it mutual inductance of coil 2 with respect to coil 1. So it will be equal to M21, which will be equal to phi 2 divided by I1. So this is phi 2 equal to mu naught N1 N2 times A times I1 divided by L. When we divide phi 2 by I1, so I1 will cancel out from here. So we will get mu naught N1 N2 A divided by L. If we compare the two results, this is M12 equal to mu naught N2 N1 A divided by L, and this is mu21 is mu naught N1 N2 A divided by L. Both are same. So we can say that M is equal to mu naught N1 N2 A divided by L. So this is our final expression. Now we are going to see the factors on which mutual inductance depends. So let's see them one by one. So as we have derived M equal to mu naught N1 N2 A divided by L. So from here it is clear that M proportional to N1 N2. It means larger the number of turns in the two solenoids, larger will be their mutual inductance. Now, second point is common cross-section area. So if area is larger, that is M is directly proportional to A. It means if area is larger, then coefficient of mutual inductance will be larger. Then next point is relative separation. Larger the distance between two solenoids, smaller will be the magnetic flux linked with the secondary coil due to current in the primary coil. Hence, smaller will be the value of M. Means separation should be smaller to make value of M larger. So we can say larger separation between two coils decreases M. Relative orientation of two coils. So if the two coils are bound in such a way that there is no flux leakage, in that case, M will be larger. So that we can understand like this. Suppose this is core material on which this is primary coil. And then on the same material, there is secondary coil. So in this case, value of M will be larger. See another situation when value of M will be smaller. Suppose one coil is like this. Suppose this is primary and another coil is like this. Suppose this is secondary. So here value of M will be very small. And next point is permeability of core material. If two coils are wound over iron core of relative permeability mu r, then their mutual inductance increases mu r times. Thank you for watching.